Good morning. Today we are going to have a class on laminar airflow. We will exactly understand what exactly are laminar airflow equipments, how they are used, and for what purpose they have been used. So coming to the learning objectives, first we will see an introduction to laminar airflow hood. Then we will see the types of laminar airflow, how many types are there, operation principles of laminar airflow, its procedure, and then we will understand its advantages and limitations. Now coming to the introduction, a laminar airflow hood, or we call it as LAFH, is an aseptic hood or a workbench. It's a primary engineering control device which provides the following services during aseptic compounding: clean area to the critical sites, immediate aseptic compounding area it is called, constant flow of air out of the work area to prevent the entry of room air, outflow of air from the hood that suspends and removes contamination which has been introduced in the work area by personals. This exactly is a laminar air flow taken by the reference by N.K. Jain. As you can see, it consists of a chamber in which there are UV lights. One light is supported, and then there is a bench which is made up of stainless steel to work. At the same time, there is a HEPA filter on the top, which we call the HEPA, high efficiency particulate air filter. This exact design looks like a clean bench or a laminar airflow hood, LAFH. Now, a high efficiency particulate air filter is the most important part of LAFH. The air within the room is taken in by the filter, passed through the peri-filter, which removes the gross contamination, lint, dust, etc. The air is then blown at a uniform velocity through the hood and HEPA filter. In a unidirectional laminar airflow manner over the critical sites, immediate aseptic compound area, HEPA filter is a particular filter which traps the airborne particles and microbes but allows the gases to pass through. HEPA filters should be fitted either or near to the clean room inlet. The pre-filter is fitted upstream to the HEPA filter, thus extending that final filter's life. A fan is also fitted which pumps the air through the filter. The filter consists of a size which is about zero point 0.3 or 0.22 microns. So this is a HEPA filter. The filter is HEPA filter is made up of a pleated fiberglass paper. Parallel arranged pleats not only increases the filter area but also the airflow between the filter. This parallel arrangement of filter medium also allows the filter to retain a compact volume. In the traditional type of HEPA filter, aluminum foils were used as spacers, which are no longer used in modern mini pellet type. Now widely used, which is this mini pellet type. The mini pellet type have a shallower depth in construction than traditional HEPA filter. Filter material is sealed to the aluminum frame with the filter as shown in the figure. One side of the filter is protected with a coated mild sheet mesh. HEPA filters provide high airflow rate, high particulate holding capacity, and a low pressure drop across the filter. The mini plate filters have a shallow depth in construction that the traditional HEPA filter as compared to the traditional HEPA filter. Filter material is sealed to the aluminum frame which within the filter. One side of the filter is protected with a coated mild steel mesh. HEPA filters provide high airflow rate, high particulate holding capacity, low pressure drop across the filter. HEPA filters removes large, medium, and smaller particles from air by inertially impaction, direct interception, and by Brownian diffusion, respectively. HEPA filters at least efficiency in removing particles of 0.22 micron size. That means it can remove the bacteria as well as fungal contamination also which is present in the air which comes from outside. So HEPA filter is the best filter which can be used for aseptic area. Now what are the types of laminar airflow hood? There are two types. One we call it as horizontal airflow hood One is called vertical airflow hoods. Now horizontal airflow hoods, as you can see in the figure which is given up by N.K. Jain. These hoods sweep the filtered air from the back to the front of the hood, and the electrical blower draws the contaminated room area using a pre-filter similar to furnace filters to remove gross contamination. The pre-filter demands timely cleanliness and replacement. Air after passing through the pre-filter is accelerated but not pressurized so that the consistent airflow between the distribution reaches the final filter, HEPA filter, present at the back position of the hood working area. HEPA filter removes 99.97% of zero point 0.3 or 0.22 micron or larger size particles, thus removing most of 0.5 microns or larger size airborne microorganisms which will be easily removed by a HEPA filter. This is the filter, this is a hood which is a vertical airflow. Yeah, coming back to the vertical airflow hoods. These hoods sweep the filtered air vertically, as you can see in the figure, which is taken by N.K. Jain. The vertical airflow hood works on the principle that the air flow between the HEPA filter and the component used are CSPs preparation should not be interrupted. When a foreign object comes in between the sterile object and the HEPA filter, the wind turbulence, zone of turbulence in the critical area, increases the foreign contamination are carried to the settled workplace, thus contaminating the injection port, needle, or syringe. Operating principles of laminar airflow. Now we'll see the operating principles. It should be placed away from the doors, traps, doors, air vents, anything that produces air current enters, entrance, whatever air enters, it creates or it comes with a contamination. So the entrance should be properly taken care. It should remain only for 24 hours. Otherwise, non-filtered, non-sterile occupies the compounding work area. Thus, when again it is turned on, it should be left on 30 minutes for disinfectant and then used. Before using laminar airflow, the internal work surfaces should be disinfected with 70% isopropyl alcohol or any other disinfectants. And a clean, lint-free cloth cleaning should be done efficiently, beginning from HEPA filter in the top to bottom and back to front motion to remove contamination. Cleaning should be done after every compounding batch and also when the work surface becomes dirty. Some materials on the surface are insoluble in alcohol, example dextrose, amino acids, thus sterile water is used initially. After wiping with the water from the surface, it is then cleaned using alcohol. HEPA filter grill should be cleaned in such a way that it does not get wet. Objects essential for aseptic compounding should be placed in the hood. Pens, labels, trays should not be placed in the area. HEPA filter not be brought into contact with cleaning solution. Aspirate from syringes and glass from ampules should be opened towards the filter. Operators during compounding should not wear any jewelries, hand, wrists, or anywhere since they affect the integrity of personal clothing, gowns, and clothes have been used. Operators should minimize talking and should avoiding cuff and the compounding area. Operators should avoid or reduce the unnecessary movements within or around the laminar airflow hood to minimize air turbulence. Smoking, eating, chewing gums, drinking is strictly prohibited in an aseptic environment. Uses. What are the uses? Given below are the uses of the aseptic or the laminar airflow hood. It has various applications, especially when an individual clean air environment is required for smaller items, particular sensitive electronic devices. It is used for specific operations in laboratories. It can be tailor-made to specific requirement of laboratories and also used for general lab work, especially in medical, pharmaceutical, electronic and industrial sectors. Advantages. Sterile area is spacious. Since the sterile area does not become hot, the plant material can stay for a longer duration of time. Bigger flask having wide lids have been used. Limitation. Airflow velocity can be overcome easily without any strict work practices and aseptic technique. Thus, an air of turbulence is created, which can introduce room contamination into critical work area. Laminar airflow hood should remain only for 24 hours. If it is turned off, it should be left for at least 30 minutes for its disinfectant before use. This whole chapter is taken from the reference of N.K. Jain, textbook of pharmaceutical microbiology, Vallabh Prakashan in Delhi. To summarize what we have learned, what exactly is the laminar airflow hood? We have seen the two types of laminar airflow hood. One is a vertical laminar airflow, one is a horizontal laminar airflow. What are the principles, where it is used, what are the advantages, disadvantages, and limitations. So that's all for now. Have a nice day. Thank you.